Welcome to our YouTube channel. I'm teacher Mara Frank and Good Study, and for this week we're gonna cover the PSLE past papers from last year, 2025, paper 2, question 16. So let's take a look. So over here we have three tanks, P, Q, and R, and the height of R is half of the height of tank Q. So Q is twice taller than R. And at first, P was filled with some water, but tank Q and R are all empty. Next, he pours some of the water from P to fill the Q completely. And then the remaining water is going inside R, but not full R. It's actually just 3/5 of the R will be filled. So then it asks him for find the height of tank R. Now, before we start with this question, let's do a simple revision of how to calculate the volume. So over here, I have a cuboid. And for this cuboid, we have three type of values, which is length, width, and height. Now the problem is, how do we find this volume? Very simple. It should be equals to length times width times height. The three values multiplied together to give us a volume. Or in another way of thinking, the length and width, if we take out those two together, the length times width, what we get will be area. And not just for simple area, it's called base area. We can also think of it as we have a lot of base areas stacked on top of each other to form the thickness of the base areas. And this thickness is called as the height. So here we have another type of calculation, which is base area times height. We can also get volume. And by understanding this, you can write down the notes over here, the calculations. And let me give you another example. So here we have a shorter tank, shorter cuboid, and taller cuboid. Let's name it as P and R. Now for these two cuboid, let's give some values. 10, 8, 11. Now, we can see the base, we have length and width are all the same for those two tanks, which is both 10 and 8. But for height, we only know P's height, which is 11. We do not know R's height, which is a question mark. Now, if I give you the volume of total, which is 2400, how do we find the height of R? Let's think about this. So, one thing is, can we calculate the volume of P? Yes. How to calculate? It just 10 times 8 times 11 and give us 880. But how about volume of R? The remaining volume should be volume of R, so we just use minus and subtraction and give us equals to 1520. So we get the volume of R is 1520 and we know the length and width, which is the base area. So how to calculate its height? Yes, the volume divided by base area. So R's height will be equals to 1520 divided by 10 and divided by 8. Give us equals to 19 centimeters. But here we have another method. You see, the base area they have is actually word relation. The same. 10 and 8. 10 and 8. So what we can do is, we can imagine we put P down below the R to form a whole cuboid. And for this cuboid, it has volume of how much? 2400. And the base area we have is 80. It doesn't change. So what can we get from the total volume and the base area? Yes, what we can get will be the total height. So we can get the total height will be equals to 2400 divided by 80 and give us 30 centimeters. But is this 30 centimeters the height of R? No, it's not. It's the total height. So what we can do is minus the height of P, which gives us the remaining part, which is 19 centimeters. So here we have another way to solve it. If we have this tank with same base areas, what we can do is you can imagine them as a one whole tank, one whole cuboid. And for this one whole cuboid, we need to use the calculation, which is to find the total volume and divide it by base area. But the height we get, it should also be the total height. Total height. So total volume divided by base area, we get total height. And then let's get back to look at this question. So over here, we have three tanks, P, Q, and R. And then, first of all, can we find how many water is inside P? Is it the whole tank? No, it's not. It's actually 4 centimeters remaining. So the height of water is not 36, but instead it should be equal to 32 centimeters. Then, how do we calculate the volume of the water? It just equals to the remaining water, 21 times 13 times the 32, and give us equals to a very weird number, which is 8736. But next, what can we get? We pour all those water into Q and R, but Q is full, but R is not full. But the information we get for Q and R is, we know the base error, which is 12 and 10, and the base error, they are what? And they're actually the same. So what can we do? What can we imagine? So we can actually imagine the P, Q, and R are stacked on top of each other to form a whole cuboid. And this whole cuboid has a water of 8736 centimeter cubes. So we can get will be the total height of water will be equals to 72.8 centimeters. But then, how do we find the height of Q and height of R? So let's take a look. The R is not filled. It's just 3/5 of the water is filled. So the water height in R is also should be 3/5. So in this case, R, the total of R, we can think of it as how many units? Yes, we can think of it as 5 units for the height of R. For the height of P will be, for the height of Q will be how many units? And that will be 10 units because it's twice relationship. But my problem is, how about the height of water? The height of water should be how many units? Is it 15 units? And no, it's not. It's just, for the R is 3 units height of water. So we have a total of 30 units. So total units of water is actually 30 units, not 15. But then this 30 units is corresponding to 72.8 centimeters. So what we can do is find 1 unit will be equals to 5.6 centimeters by dividing by 13. Now 1 unit height is 5.6 and 5 unit, which is the height of R, should be how much? And that will give us the answer. Will be equals to 5.6 times 5 give us 28 centimeters. So the answer is 28. Question solved. Very well done. Now let's do a summarize of this question. So at the very beginning, we can see the volume, the tank Q and tank R, the information we get is actually the base area they have is actually what relation? Yes, they have the same base area. So for cuboid with same base area, we can use a calculation which is the total volume divided by total base area, we will get the total height. But if we know any of the two values, if we know total volume and total height, we can also get back the base area. So that is called know 2 get 3. So if we know any of the two values, we can get last 3. The last one. It's called know 2 get all 3. So student can write this down. And also, you can try this question again by covering all the steps. Now, if you want to learn more about PSLE, you can try to scan the QR code to join our study group. I will solve doubts over here. And then you can also contact me directly. And don't forget to subscribe to our YouTube channel. And see you soon in our next video. Bye!